Bismillahirrahmanirrahim. Find the derivative of the function f of x where f of x is equal to x. Since the function f of x is equal to x is defined on the domain of the domain d is equal to r is the set of Argand number. That is at this point, at the point x, the value of the function is equal to f of x and is denoted by y. This point is a point on y axis. When we add the small increment del x in the independent variable x, the next point will be x plus del x. This point is also a point of the domain of the function f of x. There, and as the function f of x is defined on the domain of the function f of x, therefore at this point the value of the function will be f of x plus del x. This point will be a point on y axis. This point is measured from the point f of x. The point f of x is denoted by y. So this point is measured from this point, and this point is equal to y plus del y. So this point is updated when we add the change in the dependent variable. The change in the dependent variable is denoted by del y. When we add this point y to the to this length is denoted by del y. This point will be equal to y plus del y, or f of x plus del x will be equal to y plus del y. This is the another notation for the point f of x plus del x on y axis. Therefore, f which is equal to y plus del y is equal to f of x plus del x, and when we replace x, when we substitute 1, the result is equal to 1, and when we substitute 2 in the function, the result is equal to 2 on y axis. So, therefore, when we replace x by x plus del x, the value of the function will be equal to x plus del x. And we have to calculate the change in the dependent variable. The change in the dependent variable in this case is del y. Therefore, del y will be equal to f of x plus del x minus y, and which is also equal to del y is equal to f of x plus del x minus f of x, as y is another notation of f of x. So replace y by its original notation, which is equal to f of x. On the next step, this result calculate the change in the dependent variable. This change in the dependent variable is due to the change in the independent variable. Therefore, we have to check the ratio between the change in the dependent variable with respect to the change in the independent variable. Therefore, we divide this equality by del x, that is del y divided by del x is equal to f of x plus del x minus f of x divided by del x. This is the ratio between the change in the dependent variable with respect to the change in the independent variable. And after that, we apply limit as del x tends to 0. Therefore, limit del x tends to 0, del y divided by del x is equal to limit del x tends to 0, f of x plus del x minus f of x as a whole divided by del x, as f of x plus del x is equal to x plus del x minus f of x is equal to x as a whole divided by del x. If suppose this limit is the limit of this function is exist, therefore this notation is we replace this notation by d divided by dx of y, which is called the derivative of the function y with respect to x. And according to the condition of the limit, as the function of f of x divided by g of x and limit x tend to some point, we apply when the function is in the form of f of x divided by g of x, and we have to calculate the limit of this function. First, we simplify, we write the simplest form of f of x divided by g of x. First, we simplify the function which is in the form of f of x divided by g of x, and after that we apply the limit to calculate the limit of this function at this point. As the function is in the form of f of x divided by g of x, first we have to write the simplest form of this function. After the simplification, this function is equal to x plus del x minus x as a whole divided by del x. Cancel x with x. In the numerator, the simplest form of the numerator is del x, and in the denominator there is only one term. Therefore, in the numerator the function is already in the simplest form, which is equal to del x. And now we can simplify the given function. The del x cancel del x with del x. The result is equal to 1, which is a constant function. And according to the definition of the limit of a constant function, the limit of a constant function is equal to the same constant. That is, when we apply limit on any constant function, the result of that constant function is again the same limit, the result of the limit of this constant function is the same constant function c. As this is a constant function 1, the limit of this function is equal to the same constant 1. That is, the derivative d divided by dx of y in this case is x, is equal to 1, which is not equal to plus or minus infinity. That is, the limit of this function is exists there, and this limiting value is called the derivative of the function y with respect to x. Y in this case is x, that is the derivative of x with respect to x is equal to 1.